right, we should be live, I believe. And I think, yeah, I think we're all good to go. Great. Glad to hear it. Dr. Blitz doesn't have the same experience with generations of gaslighting apologetics tactics, so he seems to wade through emotional bait traps they set and just offers good conversation. Oh, yeah, that's probably it. Yep, definitely didn't have that. I was lucky in that regard, I suppose. Welcome, welcome. Howdy, howdy, everybody. All right, we did just get started, so if you're just joining us, you know, no worries. There are no questions yet, but we'll get some, I'm sure. Good luck on the job. Well, I mean, we'll see. I think that they're done with interviews now, so the question is who do they call? I spent so long editing the video for this morning, the video on WR102, but it's a really cool star and I wanted to include a lot of good details. Right. Quantum information PhD student here. I really don't know where to go when I hand in my thesis. Well, if you do quantum information, people will be begging you to work for them. Quantum information is like huge deal. You'll have jobs knocking on your door. Do you and that black chemist get along? No, he's a grifter. I did have a neighbor who once took the time to explain some basic planetary formations. The only physics I had until later. They also showed me Star Trek. Star Trek is good. Why haven't we had an Einstein in over a generation? Do we need a new Hubble instead? Well, it's just not clear if there ever will be any Einsteins again. The amount of, or at least not for a long time. The reason why, I mean, Einstein was obviously brilliant, but he was also born at the right time. He was born he was born early enough or right at the right time so that he would be in his 20s when all of these fascinating new discoveries were being made about the photoelectric effect and the existence of electrons and all of this stuff. Like quantum mechanics was basically, you might say, it was born in 1900, and Einstein was 21. So that was perfect timing. So it's not just a matter of brilliance, it's a matter of timing as well. And it's just not clear that we're going to have another moment like that, at least not for a long time. What do you think about Avi Loeb? Avi Loeb is strange. So I have a co-author who's one of his co-authors, and my co-author is totally normal. And Avi Loeb, when he writes with my co-author, they're totally normal, good papers even, like theoretical cosmology papers. And then Avi Loeb also writes like nonsense blog posts about aliens. So I don't know. Sean Carroll says all the low-hanging fruit is gone in physics. Yeah. What is a group cohomology? A cohomology is a type of map, or a cohomology is it a filtration? What's the right word? It's a quotient, I guess, of the kernel of a map to its image. The image divided by the quotient, I'm sorry. No, the image divided by the kernel. I'm not sure what a group cohomology is. I guess you would need to specify what the maps are. But as you can tell, I don't really do cohomology all that much. I don't really need to. That's very algebraic. Can you explain nuclear fission? Yeah, so there are certain elements. These are elements that are generally heavier than iron. So think like uranium, think plutonium, think lead. These kinds of elements, it turns out that if you were to split, it turns out that the stability of those elements, they get more stable the lighter they get. And so most of them are pretty stable, all the way up to like 83 or something like this. However, if you get even heavier than 83, they become so unstable that they start to want to spontaneously fall apart. And so what happens is that you can either let this happen on its own and some atoms will just spontaneously break apart into two atoms, or sometimes you can shoot a neutron at an atom and that will be enough to cause it to split in half because that's a way more stable configuration. What do you think about string theory? I think that it's probably a theory of quantum gravity, just not for our universe. Can you press the button for Ian's shock collar? That's a good joke. Do you think quintessence is real or no? I'm pretty agnostic about that. Have you discussed the recent solar storm CME? Any thoughts? Apparently, I missed it last night. Apparently, the aurora was visible everywhere in the contiguous 48, or the lower 48. Whoops. I haven't discussed it yet, though. Although there's supposed to be a bigger one coming soon, so maybe I'll be able to see something then. How do scientists measure the size of a star? Usually it's through modeling. You can't directly measure these things. They're too small. Are microscopic black holes likely? Likely, maybe not. But possible, definitely. Do you think we will find another element? Yeah, almost certainly. Northern lights will be visible tonight? Possibly. I'm pretty far south. I'm in Arizona, so we'll see. Maybe the aurora will also be visible tonight, but knowing my luck, it won't be. And I could have just gone outside yesterday. I knew that it was visible in Montana, but I just assumed that it wouldn't be visible here. Is something can come from nothing a contradiction? I don't think so. What pure math courses do physicists take? Physicists, well, okay, so you need calculus and then you'll need differential equations. But physicists, at least when I was an undergraduate, there weren't a whole lot of pure math courses beyond those that were required for a physics major. That said, a lot of physics majors do take math classes. If you're an astrophysicist, you should be able to guess my star sign. Well, I'm not an astrophysicist, so there you go. Favorite TNG episode? It might be The Measure of a Man. Yeah, it might be that. Why do all physicists wear round glasses? I think round glasses are just in style right now, or they're just trendy. I don't know. I just like them. How do they estimate the distance of a star using its light? So first you have to figure out what it's made out of, so you can kind of estimate how far away it is. So you can estimate how bright it is. And then you can, well, I mean, there's a few different ways. So you can analyze its spectrum, and that will let you figure out things like what it's made out of. And then you could use its spectrum to estimate how bright it is, and then from how bright it appears to be, you could estimate its distance. But we don't actually use a star's, like, the amount of light that a star gives off to figure out how far away a star is in our galaxy. We use something called parallax, or sometimes we use I think that we use Cepheid variables for stars as well. But anyway, the point is we don't just like look at a star. We use other methods like parallax, at least for nearby stars. For distant stars, I actually don't know off the top of my head what method is used. What was your GPA in high school? I had a 4.0. In other words, guess? No. I mean, parallax is most definitely not guessing. Parallax involves using geometry to determine the distance to a star from two different perspectives. James Speck sends $5 to ask, is there a potential that elements are being created in the heart of stars due to entropy which could not have been created in earlier star death? You can't really make elements heavier than like iron or nickel in the heart of a star. All the other elements are either made during supernovas or during neutron star collisions, or, you know, these kinds of extreme events. You'll never make anything heavier than that just from fusion. What was my GPA in university? I think it was 4.0. I may have gotten one A- at one point. No, I think the A- was in grad school. Herman Preet sends $10 to ask, well, thank you, by the way. I was watching the recent video that posted an hour ago, and I recommended turning the guest down because when you were reading the abstract, I couldn't hear you at all. Well, so that's hard to do mid-stream. I can't, like, I don't have two separate audio streams once I'm editing. But if somebody mentions it during a live stream, then that somebody else is too loud. That's good to know. What is your PhD dissertation all about? It's about something called conformal geometry. It has applications to the ADS-CFT correspondence, which is a thing in string theory. It also has applications to general relativity. Island of stability, do you think they exist? I hope so. I'm not a nuclear physicist, so I'm not going to have like a well-informed opinion on it, but it seems at least like possible and perhaps even plausible. Dr. Blitz, could you please explain redshift? Yeah, so redshift and blue shift, redshift is just the opposite of blue shift. Redshift and blue shift are just the Doppler effect, but for life. Not life, but for light. So you know how like when an ambulance is driving towards you, it gets higher pitched, and when it's driving away from you, it gets lower pitched? So if a light source is flying towards you, it gets bluer. If it's flying away from you, it gets redder. And so one of the ways that you can think about the expansion of the universe is that all of the galaxies are flying away from us, and they're flying away from us at different speeds, and that will affect their color. They're red. They're redder, hence redshift, because frequency and color are very closely related. Are you working on a paper now? A lot. I'm working on a lot of papers. I'm always working on papers. That's the date. That's the job, right? Do singularities denote ontology or mathematical pathology? My guess is mathematical pathology. How can the future exist in the block universe? Don't get it? Well, look, in the block universe, past, present, and future all exist. They exist in the future, not in the present, and not in the past. Or the future exists in the future. Think of the future as like a place rather than a time. And then it's just not so surprising. Like, I'm here, I could be there, or I could be there. If I started walking, I'll be there soon. If I was walking, I was there earlier. James Pesh, sends $10 to ask the question, do you think the low-hanging fruit is gone in physics? And what is your opinion on how science communicators are handling the celebrity influence of communication? Those are two very unrelated questions, but I'll try to tackle them both. So at least in fundamental physics, it seems like the low-hanging fruit is gone. Yeah. And the reason I say that is because what makes low-hanging fruit perhaps low-hanging is that you have access to a whole bunch of unknown or poorly understood experimental results. And if you want to do fundamental physics, and these are like fundamental experimental results, if you want to do fundamental physics, then you have access to all of this data, all of these puzzles that you can then study. And so perhaps that's what makes fruit low-hanging in fundamental physics. We don't have that right now. All of our models are so good at matching experiments that there's just nothing really there. Regarding science communicators who are and their handling of celebrity influence of communication, I haven't seen it become that big of a problem. We'll see. Neil deGrasse Tyson is still, as far as I can tell, is still pretty grounded. He doesn't say ludicrous things. Michio Kaku does say some kind of ludicrous things, but like Neil deGrasse Tyson is a much bigger science communicator, and I think that he seems pretty grounded. He still mostly stays in his lane, not always, but mostly. And so, yeah, I think that it's not a problem yet. Is temporospatial ontology phenomenologically contingent? I don't see why it would be. Linear algebra for operating system development. What about it? What is quantum gravity? How is gravity at the quantum level? So quantum gravity is the name that we would give to whatever the theory of gravity is that describes gravity at the microscopic quantum level. Darth Smack sends $5 to ask, what's your opinion on many worlds interpretation of quantum physics? Can you expand on why or why not it's likely? So I like the many worlds interpretation. I think that it's kind of like the simplest explanation, and absent additional evidence, it's the one that we should take seriously. The reason why is because you don't have to add anything else to quantum mechanics to get many worlds. If you want the Copenhagen interpretation, you have to add this feature of quantum wave function collapse. If you want a dynamical collapse interpretation, you have to add a feature of dynamics. If you want a Bohmian mechanics, you have to add another equation that describes the particle motion in response to the wave function. So the many worlds interpretation doesn't really require anything else. And so that's why I think that it's like Occam's razor says that we should probably believe that. Now, Zafjez sends 100 Norwegian kroner. Let's say Big Bang, Big Crunch is true. What would be the mechanism preventing the universe from becoming a black hole in the crunch? The same reason why the universe wasn't a black hole in the very early universe. A black hole formation requires not just density, but a density differential, right? If you just have a really, really dense, if the entire universe is really, really dense, where would it collapse to form a black hole? It would need to, there would need to be a place that's less dense and a place that's more dense, so the more dense place attracts the matter from the less dense place and collapses. But if it's the whole universe that's dense, there's just not a place for it to collapse to. It just becomes uniformly more dense. I heard Dr. Tyson has 9 doctoral degrees. Do you know this to be true? I'm sure he has 1 regular PhD, and then I'm sure he has a bunch of honorary degrees. But those don't really count for anything. Thoughts on dark matter being disproved? I haven't heard that. Can you break cube square law? And is the human soul quantum? Those seem completely unrelated. The cube square law is just a fact that like bone size or bone strength corresponds to the cross-sectional area, whereas mass corresponds to the volume. And so things can't get much bigger than a certain size because their bones don't grow as fast as their volume does. I don't think humans have a soul. Regarding your second question. Seabar, thank you for the budding heart. That's 300 gems. I appreciate you. How is it possible that JWT can transmit data to Earth over such long? So it's JWST. It's like 1 million miles away, but it just has a radio antenna. What does Michio Kaku do that makes him go out of his lane? No, Michio Kaku is just kind of off the deep end. He says a lot of things as if they're true, but they're like complete wild speculation. Like he talks about string theory as if it's like been proven true, but like it's definitely not. Is spacetime curvature a phenomenological simulacrum? I have no idea what that means. Is the expanding of the universe faster than the speed of light? The expansion of the universe doesn't have a speed in miles per hour or meters per second. The expansion of the universe is a doubling time. Think of it as like how long it takes for the universe to double in size. As you, like, I mean, as I'm sure you can infer, like that is not something that has like a meters per second value. What's your opinion on DS holography? I'm torn on it. I would love for it to work, but it seems like it's fundamentally characteristically different from like ADS holography and even perhaps like asymptotically flat holography. So I'm not sure if it can even make sense because you end up with a space-like manifold that doesn't have dynamics on it. So somehow you have to get dynamics out from something that has no dynamics. What is electricity? Electricity is the flow, you might call it like the flow of energy, or the transformation of energy from electric potential energy to some other kind of energy. And this can take place over a distance. Now, Woe sends $10 to ask the question, are there any science fiction-y things, mostly Star Trek type, that are becoming more realistic with time? Well, cell phones, like the flip phone, that was inspired by the Star Trek communicator from the 1960s, where they have the, and then they flip it open and they talk to it. That was, the flip phone was inspired by that. All of the computer stuff is becoming more and more realistic. Things like the transporter, probably not. The replicator, we haven't made any progress on. Warp drive, we haven't really made any progress on. Phasers, yeah, maybe phasers. Phasers, like, you know, we have laser beams that are, you know, like in development by the military, so maybe. Do you think the discovery of quantum entanglement lend credence to simulation theory? No, not at all. Oh, okay, I already answered that. When is cybernetic implants coming? I don't know, maybe they might already exist. Could you please explain why local reality isn't real? So it's not that local reality isn't real, it's that one of three things must fail. Either one, you have something, either one, you lose locality, meaning that things can influence other things faster than the speed of light. Two, you lose reality. That doesn't mean that like existence ceases to exist. It just means that quantum systems don't have well-defined properties until after they're interacted with, or until, you know, they collapse into some basis state or something like this. And then the third thing is you could have you could fail to have like measurement independence. Basically, it could be the case that the universe is kind of conspiring to make quantum mechanics appear true. If you jump off the Empire State Building till the end of time, do you go through without touching? No. What are black holes made out of? Well, they're made out of a lot of things. Most black holes that are around today are going to be made out of the dead cores of, or the, you know, the iron cores of stars that then collapse to become neutron stars and then collapse to become something more extreme that we don't understand yet. Will we ever be able to maneuver space-time? I don't know what you mean by maneuver space-time. Space-time isn't somewhere, so it'd be hard to make sense of what it means to move space-time around. Yeah, I'm imagining the hologram I'm imagining the hologram at future null or future space-like infinity. Are you imagining it at like future null infinity or something? Because there is no future null infinity for de Sitter. I mean, future null infinity intersects with the future space-like infinity. Is Perpetua mobile possible? No, not really. Because anytime anything moves, it's giving off a tiny bit of energy. And so you will always inevitably lose some amount of energy. What do you think about timescape cosmology? Generally, I think that it's probably not correct because it kind of relies on this fundamental assumption that gravity doesn't really average out nicely. But I think that there's probably good theoretical reason to think that that actually gravity does average out nicely. Are there any relevant physicists proposing a deistic framework for a physical description of reality that is potentially worthwhile, i.e. mathematical Penrose inquiries? Do your best with that word salad. I have never seen a physics paper where some sort of deistic or theistic framework is proposed to explain something. I've never seen that written. What are your views on wormholes? Can we travel to another galaxy through wormholes? Wormholes, as far as we can tell, wormholes are almost certainly not stable, and they require negative mass to stabilize them, and we don't have that. So it seems like you just can't make wormholes in like any sensible way. Woe sends $10 to insert sappy message about how we all love you and your content. Keep doing what you do. Replicators in the holodeck would be dope. Yeah, they would be. Darth Smack sends $5. Can you explain entropy? You mentioned before it's misrepresented often as things being mixed up. So no, it's often misrepresented as things being disorderly. Mixed up is actually a really good description. Entropy, I mean, Willard Josiah Gibbs referred to entropy as mixed upness. And that's a totally good way of describing it. But really, if you want to think about entropy in like in an exact way, what you should really be thinking about is the number of ways the microscopic details could be so that the macroscopic details stay the same. And the more ways you could have the microscopic details without changing the macroscopic details, the higher the entropy. And so the mixed upness, that kind of follows, right? If you have something that's really, really mixed up, then like you could swap two particles or you could rearrange two particles and it won't really affect the macroscopic scale variables. What branch of physics receives the most academic funding, and if it were up to you, what would you prioritize? So generally speaking, condensed matter receives a lot of funding, like a lot of funding, because they're very, very close to application. Astronomy and astrophysics also receive a lot of funding, like large government scale funding. And honestly, I think that the priorities are okay. I mean, obviously I wish that my area got more funding, but you know, like as far as allocation of resources go, I think it's probably okay. Best reference to start on mathematical physics, particular to mathematical relativity? Well, just pick up a book on general relativity. Like if that's what you want to do, you need a book on general relativity. I would suggest starting with Sean Carroll's book, Space, Time, and Geometry. It's the book I learned relativity out of. And then once you're done with that, then move on to Misner, Thorne, and Wheeler, MTW. It's a book called Gravitation. It's also called The Bible. And then you will need to read a lot of differential geometry textbooks, or read a lot of differential geometry papers anyway. Could you explain what are brains in theoretical physics? Like I'm 2, not 5. Do you mean like the stuff in our heads? They're just like wiggly bits that think. What's your specialty area? What's your specialty area in physics? I do relativity, and so that touches on some cosmology, that touches on some black hole stuff. I also do differential geometry, which is a branch of mathematics. It's a branch of mathematics that is basically the language that relativity uses. So yeah, that. How long does it take to know what you know? Well, I didn't know what I knew 10 years ago, and now I know what I know. So I don't know, around 10 years, let's say. What does differential mean? It just means like a small change. That's usually what the word is used to imply. Are you currently involved in any research? Yep, I have several projects that are currently ongoing. One project that I may be starting soon, but I don't even have like a handhold to start, but I'd really like to start it because I have a conjecture that I'd like to prove. And then I have a few other things going on. I don't actually have any physics-y projects. I sort of have one physics-y project, but it's not like super physics-y. But you know, I have some other stuff that I'm thinking about that I just haven't started yet. Is metric tensor curvature a self-referential ontological map? I have no idea what that question means. So then what is differential geometry or differential equation? A differential equation is an equation that tells you how something changes based on, you know, whatever else you know about the thing. Like maybe the thing changes in proportion to how big the thing is or things like this. Differential geometry is just the in some sense, it's like the most general form of the geometry of curved things. James Pesh says, sends $5. Thank you, James. I've loved this conversation. I have to go to another thread, but Dr. Blitz, thank you, and please carry on. You're being very cool. I appreciate that. Anyone else lose audio? Hopefully not. Hopefully audio is good. No, branes is in extra dimensions from string theory. Oh, they're basically just surfaces. They're just higher dimensional surfaces. It's spelled B-R-A-N-E-S, not with an I. Do you have to be good at math to be a physicist? You don't have to, but you don't have to be like a math genius. However, there is data that says that if you didn't score in the top 75 or the top 25% of the, basically if you scored less than a 600 on your math part of your SAT, the odds of you succeeding in a physics major and then going to grad school is very low. So take that with a grain of salt. These are statistics. Statistics don't apply to individuals, but they are general trends. Darth Smack sends $5. Do you see any potential forks in the field of physics in the nearest future, like how quantum physics forked off from classical physics? Really, it's really hard to foresee. I can't predict any such thing like that. You're transported to 2000 BC. How do you find a magnet out in the wild? I guess what you could do is you can make a small compass. Right, making a compass isn't that hard. You just need to find some iron. Now, finding iron in 2000 BC might be kind of tricky, but find some iron, just like a little tiny piece of iron. Make it into like a needle if you can, like smash it down or whatever, or just get a shard of iron even, and then put it on a leaf, float it in some water, and then just carry it around. And if there's a magnet nearby, hopefully it'll start to move around wildly. But magnetite was rare. I mean, it is pretty rare, right? Let's face it, physicists have no idea what's going on in the quantum world. I mean, I don't think that's true at all. If we had no idea what was going on in the quantum world, then we wouldn't be able to make stunningly accurate predictions about what's going on in the quantum world. What, according to you, are some of the unsolved problems currently in physics? I made a video about this like a week and a half ago or 2 weeks ago. But roughly, there are problems about dark energy and dark matter. There's problems about why there's so much matter rather than antimatter. There's problems about the foundations of quantum mechanics, like what's going on, like why is it that we observe one outcome rather than many outcomes, even though things are in superposition. And then there's questions about how gravity behaves at the microscopic scale. I think that those are probably my top 5 most interesting, hardest unanswered questions. Does quantum gravity permit retroentropic ontosemantic conversion? Okay, now you're just trolling. This has got to be a troll. How often are you dealing with and solving partial DEs? Not often, but when it comes up, I need to be able to do it, or at least be able to understand them and, like, you know, kind of describe them qualitatively, describe what families of solutions look like, etc. Is it true the guy who won a Nobel Prize for string theory quoted on stage, if you think you understand string theory, you don't understand string theory? Nobody has ever won a Nobel Prize for string theory. But I think that you're trying to mention Richard Feynman, who said, like in the 60s, if you think you understand quantum mechanics, you don't understand quantum mechanics. And that may have been true then. It's probably not true now. I wanted to start an interesting conversation on the future of holography, but unfortunately you don't want to acknowledge that ADS-CFT cannot describe your universe. I don't think ADS-CFT describes your universe. Why would I not want to acknowledge? Like, that's obvious. Our universe isn't an ADS. isn't asymptotically ADS. At least it's not clear that it's the evidence that we have suggests that the universe is not asymptotically ADS. Maybe we'll get new data that corrects the record, but yeah, of course ADS-CFT doesn't describe our universe. I never said it did. It's a weird claim. What is ADS-CFT? ADS-CFT is it's like a theoretical correspondence between two different types of two different types of universes. So you can have one universe that has a type of gravity in it, and it's a specific kind of universe. And you have another universe that doesn't have gravity in it, but has one fewer dimension. And it turns out that if you study these two different kinds of universes, there's a very, very close relationship between them. Everything that you can say in one can be described in a different way in the other. And that's kind of shocking. It's like very surprising. You just said DS holography cannot work. Well, just because I say DS holography can't work, that doesn't mean ADS holography can't work. I'm just not convinced that de Sitter holography will work. Like if you want to do holography, it might require ADS, in which case maybe holography doesn't apply to our universe. That's like crazy. Have you ever heard of strange matter or quarks? Yes, I've heard of both of those. Strange matter is matter that contains strange quarks, and quarks are fundamental constituents of matter. They make up the heavy baryons, or they make up baryons, really. And, well, and mesons, I guess. Why does light have no mass? Well, if it did have mass, it wouldn't be light. How does one get an intuitive understanding of classical mechanics? Classical mechanics, okay, so it depends on what classical mechanics you're talking about. Some of classical mechanics is like the most intuitive stuff you can do in physics. It's like you throw a ball up, it falls back down, like that we understand. But some of the more complicated classical mechanics stuff that just comes, like intuition comes from exposure. That's where intuition comes from. So you just have to do exercises. Any opinion on Richard Dawkins? He's done a lot for evolutionary biology, is my understanding. Oh, I think I have a cat hair in my mouth. Yep, there it is. Why was there a little more matter than dark matter in the universe? Why wasn't it annihilated? So dark matter and regular matter don't annihilate each other. You're thinking of matter and antimatter. And we don't know. We don't know why there's more matter than antimatter. Do you believe white holes exist? I don't. I heard the Weizmann Institute of Science had important physics research lost. Is this true? I haven't heard of that. It sounds made up. Is strange matter and quarks theoretical? Quarks are not theoretical. Quarks have been basically empirically measured. Like we have a whole bunch of properties of quarks that we've measured. Strange matter, also not theoretical, but stable strange matter is. It might be the case that you can't form stable strange matter, even with gravity helping you, for example. Do you think quantum fields are real or just a mathematical model? I'm pretty agnostic on that. I kind of want to say that they're real, though. What do you think about the whole 3I Atlas mess? It's a comet. Are we living in a simulation? I don't think so. What interests you the most about space? The whole thing, the universe, the cosmology. It's like the whole thing. Where did it come from? Where is it going? Who's a physicist that you look up to? I mean, like a living one? Roger Penrose. A dead one? Albert Einstein. Are you using advanced mathematics such as category theory? No, I'm not using category theory. I tried to learn category theory last year and it went poorly and I gave up because I had other things that I'd rather focus on. I use differential geometry mostly. I do some functional analysis stuff, but I mostly just do differential geometry. Now, G3 Rain sends $5 to ask the question. My understanding of QCD is that it binds quarks into nucleons, but how does QCD bind nucleons to each other? Yeah, so essentially what you can end up with is you can end up with color dipoles or color quadrupoles. Essentially, even though the quarks themselves are made of, even though the quarks themselves are color neutral, they still have some color distribution inside of them. And that can kind of produce attractive forces between the two in much the same way that like you can have a neutral atom attract another neutral atom, right? Just via the van der Waals effect, van der Waals force. Do you think Wolfram physics could describe the universe? No, I don't think so. Thoughts on why dark matter and antimatter is not more detectable if it's so prevalent? So antimatter is not prevalent. That's why we don't detect it, because it's not prevalent. Antimatter is very easy to see. Dark matter is not detectable because it's dark, even though it's supposedly very present. That's what dark means. It means that it's very, very hard to detect. Your thoughts on CPT invariance? Well, it follows from Lorentz invariance, and if Lorentz invariance sticks around, then so will CPT invariance. Could you use entanglement of electrons to transmit data over vast distances? No, you cannot. There's something called the no communication theorem that proves that you can't. Do you believe time-space wraps exist? I think you mean warps. I don't know what you mean by time-space warps. Dark matter should be more detectable if it existed. No, not if it's dark. That's like the whole thing. That's the whole thing. If it's dark, then no, it's not going to be more detectable. I mean, we can detect its gravitational influence, but we can't detect it earlier. We can't detect it via other mechanisms. How much of the periodic table could you eat before you died? 1 gram of each element? Not very much of it, I don't think. I imagine if you ate a gram of lithium, you'd probably die. And that's like the 3rd element. So is dark matter just assumed because of basically inference? Well, yeah. So we see a certain amount of matter. We see a certain amount of gravity. The amount of matter doesn't match the amount of gravity. And it seems like across scales, like whether you're looking at galaxies or galaxy clusters or the entire universe, it seems like that's the case everywhere, that there's more gravity than we would expect. There's more gravitational influence than we would expect in all of these cases. More gravitational lensing, the CMB behaves exactly as if there was dark matter. So there's a lot of different aspects that allow us to indirectly infer that dark matter exists. If we had a superconductor strong enough to be affected by the Earth's magnetic field, could we make flying ships like in Star Wars? I don't understand the question. Superconductors reject magnetic fields. Are you talking about like because they reject magnetic fields they could fly? No. The Earth's magnetic field isn't uniform, so you'd be able to fly in some sense like along magnetic field lines, but that wouldn't allow you to just like maintain a constant height. Does he read his YouTube stream? Yes. How did the Big Bang happen? That's a great question. I mean, kind of the mainstream answer uses inflation. So the way to think about it is that before the Big Bang happened, you had a universe that was essentially empty and cold, but it had a lot of potential energy stored in something called an inflaton field. And then through various mechanisms, depending on the theory, you get different mechanisms. That inflaton field basically dumped its energy into the other quantum fields that exist, which caused the universe to get really, really hot because there were a ton of particles that were basically put in place like all right next to each other in one tiny area. And then that caused the Big Bang. That's the inflaton model, or the inflationary model, rather. Tectonic plates magnetic. As far as I know, tectonic plates are not like magnetic things. Why'd you go to uni? It's pointless. I don't think it's pointless. What is outside the universe? It depends on your view, but generally the word universe is defined to mean everything, so it doesn't make sense to talk about outside the universe. Does the second law of thermodynamics leave any room for eternity? Yeah, it depends on how applicable the second law of thermodynamics is to the entire universe. What's the difference between a physicist and other science math-related specialists? So it's just a different field of science. So if you're a biologist, then you study life. If you're a physicist, you study matter, you study motion, you study the universe. Like, there's just a different field of study. What's the main thing that pushes you away from believing in God? The lack of good arguments for its existence. whoever element may, I don't know what that question means. How do physicists create formulas? There's kind of two ways. The first way is essentially from first principles, like from first mathematical principle. So you have some kind of like intuition for the way a thing should be, and then you kind of derive mathematics that lead you there. You kind of rely on like some intuitive physics that you already understand, and you build a new equation that way. The other way is that you just might have some new data, and then you kind of find an equation that fits that data. What do you think is the most important aspect of physics? I don't think there, maybe symmetry. Yeah, symmetry is probably the right answer there. You think because you got your little degree, I have 4 little degrees, thank you very much. Could a whole nebula of antimatter survive in a void area of space? Not, I mean, in principle it could. It depends on how void the void is, but there would always be an edge between where the antimatter is and where the matter is, and you would just see gamma rays being emitted from there. Sorry, I have to hydrate some because you guys are asking a lot of questions, which is good, but it's still a lot. How does quantum gravity work? If I knew, I would go get my Nobel Prize. Big Bang, was the expansion uniform like an expanding perfect sphere, or could the edge have expanded at different speeds, causing pockets or whatever it expanded into to form? So there wasn't an edge for the Big Bang. The Big Bang was not an explosion at a place. The Big Bang was the expansion of space itself. So it was the entirety of space getting bigger. Are parts of the universe unreachable to us due to expansion? Yes, so long as the expansion continues. Why wasn't the Big Bang a black hole instead? Because there wasn't a strong overdensity. So black holes form when there's a lot of stuff in one place and nothing else surrounding it. But if it's a pretty uniform, if the universe is pretty uniform, then you're not going to get a black hole. There's just no, like, it won't collapse in any one particular place. Do you think space-time could wrap or fold in a way that allows time loops or shortcuts through space? In principle, yeah, our universe, the thing that you're looking for is whether a universe is simply connected. I suspect that our universe probably, well, I suspect that our universe probably is simply connected. Now, do we have any evidence of that? No, but we also don't have any evidence that it's not, so. Do you think heat death is the most plausible ending to the universe? Not anymore. No, there's data that's come out in the last few years that's really called that into question. Why do people think the Earth is flat? Because it kind of looks flat. Kind of. If you don't think too hard. What was before the Big Bang? Inflation. At least that's the kind of mainstream view. I'm an MIT PhD physics graduate. What is it you truly want to discuss? I don't know what that question means. I'm answering questions from a lay audience because I like doing that. What are your thoughts on the rotating spinning universe model in regards to solving the microwave background radiation discrepancies? I haven't looked too closely into them, so I'm not going to make some definitive statement that they're definitely wrong or they're definitely right. I wouldn't be surprised if our universe had a preferred, if our universe had a preferred axis of rotation. We would just need some good explanation for why that's the case. What determines the plane a star system or galaxy rotates on? The fabric of space-time is confusing. So it just depends on how the thing formed. So like if you have a whole bunch of stuff, a whole bunch of like randomly scattered particles all gravitationally collapsing towards each other, they will spin around each other. They will eventually spin around each other in a preferred direction just because of the randomness. So it's essentially random. Velvet with the 2 Canuck bucks asks, do you think time is fundamental or emergent? I'm agnostic on it. Really, I don't think that we have enough information to say so. To say either way. Could there be multiple universes by position instead of, as most think, multi-dimensional? I don't know what that question means. By the way, please don't spam questions. Could light slow down when going through matter because matter contains more space because it distorts space? No, we understand why light slows down in matter. It's because light becomes coupled to the, the electrons basically that make up the matter. Thoughts on the concept of inversion in the Tenet movie? I didn't understand that movie well enough to have any thoughts on it. I've been wondering about whether or not black holes can bend light and let you see into the past. Well, you can always, whenever you're looking, you can see into the past because the light was emitted before it got to you. So you're seeing something as it was when it emitted the light. But yes, black holes can bend light. How did light and matter come to exist? Well, matter is just, the way that we describe matter, like particles and stuff, is just an excitation of various quantum fields. And those excitations can arise due to fundamental particle interactions, or fundamental field interactions, I should say. Now the question is how did that come into existence? Maybe maybe there's always been excitations in the matter fields. And the electromagnetic field, that would just, if there's an excitation in the electromagnetic field, that means that there's light. Maybe not. We just don't really know at this point. Will travel between the stars be possible in the future? I don't think it'll ever be easy like it is in Star Trek. What do you think is the best, most active field to do a master or after physics degree? So astrophysics, in particular exoplanet stuff, is really, really popular right now, and condensed matter is always lucrative. Are Dyson spheres possible? No, not really, because you would need like something that is incredibly strong to hold its shape when you wrap around a star, because the thing would just be enormously large and would have enormous stresses on it. Could our universe be one of no disrespect intended, but have you made any contributions to the field yet? Just curious. Yeah, I have like more than a dozen published papers. Yeah. Is fusion the future of nuclear energy? I hope so. Do you have a least favorite area of physics? Condensed matter. It's just hard. Condensed matter is really hard. Is the 3i Atlas real? It's real. It's just a comet. Could a black hole be created by heating an object to extreme temperatures because of E equals mc squared? Yes. Yes, it could, at least in principle. I made a video about this a while ago. How to cook a black hole in your oven. What's the difference between general relativity and quantum mechanics? They're just different theories. They describe different things. One describes gravity, the other describes microscopic stuff generally, and light. Is the idea of white holes something that scientists take seriously? Not really, no. Can you give an elevator pitch for what the subject of condensed matter is? So condensed matter physics is basically, you can think of it as the study of like structured matter. So solids and perhaps liquids. So like various crystals, superconductors, topological, like it's basically think of it as like the physics of material science. That's kind of the way to think about it. Now Boyce sends $2. When did you know that you wanted to be a physicist? It was probably like sometime between 7 and 9. I saw a picture of a black hole on the internet and I thought that that was the coolest thing. Now Velvet sends 2 Canuck bucks. Why a black hole rather than a hole of color? Okay. You spent $2 for that joke. I see what you did there. Why doesn't light create a sonic boom? Well, because light isn't really pushing the particles around, pushing the air particles around. Or the air molecules around, I should say. If you could get only one question answered from within physics, what would that question be? I'd like to know what quantum gravity is. Before I cook a black hole in my oven, what do they taste like? Not a whole lot. Can quantum field theory explain how gravitons, hence gravity, escape the black hole? Gravitons don't escape the black hole. Black holes aren't just emitting gravitons merely by existing, in the same way that an electron isn't just emitting photons merely by existing. Now, you can ask how gravitons are produced when a black hole wiggles around, like during an in-spiral, but that's because the space-time outside of the black hole is fluctuating. Now, can quantum field theory explain that? No, quantum field theory has no chance of explaining black hole collisions at this point. What are ways that can cause a planet to stop rotating? Something hitting it? I guess you could attach rockets to point in the opposite direction. What are your thoughts on the one electron theory? It's kind of defunct. Like, it's been defunct since, you know, maybe the 50s or the 60s. So you only answer people who give you money. Got it. I am gone, bro. Take care. No, they just get priority because of course they do. Bro's salty. What is the proper term for a perturbation in the quantum field that does not give rise to a full-blown particle? You could just call it a non-particle state. I don't know if there's like a proper name for it. Do you have a favorite interpretation of quantum mechanics? Yes, I prefer the many worlds interpretation. Will we ever see Kitty again? She doesn't really like to be in my office. I saw a red aurora borealis last night. What happened? Well, sometimes the aurora borealis is red. But there was a large solar storm or a solar flare that hit the Earth last night, so that's why you saw it. Does gravity exist? Yeah, definitely. Are you looking for postdocs? Yep. How does time speed up by moving faster? At least from what I've heard. Time slows down. So if somebody is moving fast relative to you, their clock will appear to move slower. And one way to think about this is just consider that everything in the universe is traveling through space-time at the same rate. And if that's the case, if you travel quickly through space, then you have to travel more slowly through time. What's my mic? It's a HyperX Quadcast. Do you think Oumuamua is a comet or an alien probe? It's a comet. It's a rock. It's a space rock. Oh. Could a 3D space with a point like singularity be mapped in 3D space having singularity at the boundary? No, at least not with the diffeomorphism. I mean, if you have a, like, I'm sure that you could probably come up with a map that maps like a zero-dimensional singularity to a two-dimensional singularity, but like, generally speaking, diffeomorphism is preserved dimension, so. Thray Atlas is still a comet? Yep. What textbook did you use for QED? I didn't take a QED class specifically. I took a quantum field theory class, and I think, let me pull up my textbooks. Did I use, I don't think I used Weinberg. God, I don't remember actually. Was it this? No, that was my classical mechanics textbook. Was it this? Was it? I don't think I used Z, but Z is a good book. Is Sakurai quantum mechanics or is it QFT? No, actually I may have used Z when I was a grad student, at least for my second course in QFT. But I definitely use Sakurai for quantum mechanics. El-Bukhari, that's a long name. Did Muslim scientists have an important impact? Absolutely. Thank you for the €2. Velvet sent 2 Canuck bucks. Thought on Bob Lazar. He's a hack and a fraud. Do you own a quantum computer? No. Mostly Gizzard sends $5. What is your favorite Mexican restaurant and why is it Filiberto's? Green chile. Filiberto's is good. My favorite Mexican restaurant. Okay, so it's a place in the town I went to grad school in, and it's not like a chain. So I don't want to say it, otherwise you'll know where I went to grad school. If you spam your question, I'm not going to answer it, by the way. I kind of want to go into astrophysics, but I feel like getting a job is very hard. What's your opinion? Getting a job is very hard. Yeah. Any recommendations for brushing up in calculus? Yeah, there are a lot of like online courses that you can use. Khan Academy is good. MIT Open Courseware is good. I've heard good things about all of them. What did you do after finish the degree? I went to go work at a university to do research. Any notable advances in quantum gravity? I mean, it depends on what you mean by notable. Like, there are advances. It's just not clear who's going in the right direction, right? Like, a lot of people are pushing in a lot of different directions. What are your views on Hubble tension? I hope that this new paper that pushes back on the standard candles of type 1a supernovas actually helps resolve the Hubble tension. Have you met Neil deGrasse Tyson? I have not. Do physicists just do math all day and measure the universe? No, sometimes there's simulations involved. Sometimes you build stuff to like run your experiments. The more degrees, the more delusion. Scientism can't even explain the observable world correctly. Okay, you don't have to be here. Research in what area? So with the university I went to go do research, it was a math postdoc. So I was doing some mathematics, some pure mathematics, as well as some more physicsy stuff. I wrote a few papers. I wrote a paper, I wrote a paper on black hole event horizons, characterizing them in a new way. I wrote a paper on another black hole thing, talking about rotating black holes in a positive cosmological constant universe. I wrote a paper on a thing called conformal warped products. I wrote a lot of stuff. It's differential geometry and relativity, basically. What's your opinion about the Great Attractor, and is it something we need to worry more about? The Great Attractor is probably just a bunch of galaxies that are being obstructed by our own galaxy. Where do you go if you want to do Physicist at home, like websites? I don't know what that means. I don't know what that question means. Is gravity caused by a gradient in time dilation? At first order, yeah. What's your professional opinion of Neil deGrasse Tyson? Well, he hasn't really conducted original research in a long time. But he does a really good job doing science communication. I think he does a good job exciting people about science, so I think that that's a good thing. How do you prove theoretical physics? Theoretical physics is just the theory side of physics, and then you go and you do experiments to verify it. It never stops being theoretical physics, though. Should dark matter just be a property of matter at some unobserved state or scale? Probably not. And the reason I say that is because if it were, then we would expect the same proportion of dark matter in relation to regular matter everywhere. But we see some galaxies with a lot of dark matter, some galaxies with only a little dark matter, and it just doesn't seem uniform. Why are imaginary numbers seemingly so fundamental in physics? Because imaginary numbers are the algebraic completion of the real numbers, and if in physics we use algebra to describe things, we use algebra and real numbers to describe things frequently, which means that imaginary numbers are going to show up. Bill Nye is not a scientist. Why Bill Nye not scientist? Because he had a degree in like civil engineering or something, or mechanical engineering. Well, it does stop being theoretical physics when it's proven, like black holes. Theoretical physics is a type of physics. It's not like theoretical physics is not like made up physics. That's not what that means. Why is liquid helium colder than liquid hydrogen? I thought it would be the opposite. I don't know the answer to that question. I'm cursing right now general relativity. What book would you recommend? The book that I used, the book that I learned out of, and I thought it was really good, was Sean Carroll's Space-Time and Geometry book. It's just a good book. It's well written, and it's a pretty good introduction. It's not nearly as intimidating as like MTW or anything like that. Is it possible we are in a matrix? I mean, like, it's possible. Yeah, it's also possible that there's an invisible teapot that's orbiting Jupiter. It doesn't mean that we should believe it. Theory, how does the math experiment? How do we test if the math is correct? It's not that simple, no. Derivative of 3 cosine 4x minus 12 sine 4x. Can you explain loop quantum gravity? Loop quantum gravity, it's not something, I never took a class in loop quantum gravity. It's pretty fringe still. But basically it's a clever way of kind of decomposing the way that we describe gravity in a way that can be quantized in like the standard quantum field theory way. The trouble is it's really, really hard to make sense of what it's even saying. What is the question behind the 3-body problem? Why is it so hard to answer? So it's not hard to answer. We know how to answer it. The question is, if you have 3 objects, three things in space, they all have some amount of mass. The 3-body problem is the problem of describing the trajectories of all of those masses as they're like orbiting each other and stuff like that. And it's really, really complicated. The dynamics are not as simple as just 2 bodies. 2 bodies, they just orbit each other. 3 bodies, it becomes chaotic. And so what you can show mathematically is you can show that there are no like closed form solutions, but you can still write down a solution. It just involves an infinite series. And so we can solve it, no problem. How close are we to fusion? It's hard to say. I'd hope like 15 years, but people have been saying that for 50 years, right? Could dark matter be ordinary matter that interacts with light energy in weird ways? Well, if it interacted with light and energy in a weird way, then it wouldn't be ordinary matter, right? Can you talk more about why we aren't confident in heat death anymore? I didn't say we, I said I. So there's been a few papers, a few surveys, a few analyses that have been conducted in the last few years that have called into question whether or not the universe's acceleration is speeding up, and if it is speeding up, whether it's speeding up at a constant rate, which is what it should be if we're headed towards a heat death, or if we have a cosmological constant, or whether the rate is changing or whatever. And it seems like dark energy seems to be getting weaker. That's what the recent analyses and the recent data seem to suggest. And so that means that heat death may no longer be the only inevitable outcome. Velvet sends $2, 2 Canuck bucks, I'm sorry. Do you think time is fundamental or emergent? I'm agnostic about it. I think that there are good arguments on both sides. Wasn't fusion achieved by NIF in 2022? So they produced more energy from the fusion pellet out than they put in from the lasers, or than was absorbed from the lasers. But the lasers themselves didn't, but they still used more energy to produce the energy that was absorbed by the lasers. So it's still not net positive in the useful way. How many bodies in our system? Oh, lots. 0-point energy, real or not? Real, unusable. Do you think Elon will get humans to Mars in our lifetime? I don't think it'll be Elon that does it. I think it'll be, if SpaceX does it, it'll be his engineers. Elon will have had nothing to do with it. Do you drink sodas? Yeah, sometimes. Is there a way to prove many world theory? You basically prove it by proving all of the other options wrong. Because it's kind of what's left behind when there's no additional mechanism. Which theory of time do you think is the most plausible? Again, I'm agnostic about it. So ZP is real, but it has no capacity to do work? Yes. At least as far as I know. I haven't seen anybody that's demonstrated that it does. Doesn't he have a degree in physics? I don't think, maybe he has a bachelor's in physics. He has a bachelor's of, yeah, he has a bachelor's of physics, which, you know, doesn't really indicate anything. So what does Elon attribute to SpaceX? Just funding? He owns it. Or at least a big chunk of it. He's the CEO. But like the people who actually do the work are engineers, right? Why do we not consider non-renormalized theories? Couldn't it just be a QFT limitation? Well, look, if we want to do QFT, in order to have a QFT that makes sense at all energy scales, it has to be renormalizable, right? Otherwise you get nonsense. What's your opinion on Avi Loeb? It's 50-50. On the one hand, he contributes a lot to pseudoscientific crackpot stuff, but on the other hand, his non-alien papers are actually really generally quite good. How prevalent are differential equations if you study A to get bachelor's of physics? Differential equations is the language of physics. That's how you do physics. What's the most important law in physics, like, you know, laws of motion, or which one do you like the most? I think the most important law in physics is probably, it's like a mathematical law that is applied to physics, namely that for every continuous symmetry that a system has, there is a corresponding conserved quantity. That's Noether's theorem. How accurate is Big Bang Theory, like percentage-wise? It depends on what you understand the Big Bang Theory to be. The Big Bang, the idea that the Big Bang is that the universe was very, very small and very, very hot in the past, that is like a scientific fact, if you will. the specific details of like the rate at which the universe has been expanding, that has like, there's like a standard version of that, which is called the standard model of cosmology, or lambda CDM. Who knows? Are physics symbols consistent around the world? Within subfields, generally, yeah. Is the universe still expanding? It seems to be, yes. What is dark energy? Dark energy seems to be something that is contributing to the expansion of the universe. Doesn't entropy cause an asymmetry at the fundamental level? No, because there is no, like, entropy is not a thing that exists at the fundamental level. Entropy is an emergent phenomenon. That's the trouble. Do you believe Bob Lazar? No, and nobody else should either. If the Big Crunch is real, the Big Bang and Crunch happen an infinite amount of times forever. No, that's not necessarily true. Your views on the theory that our universe is inside a black hole? I think it's false. I think that, in fact, one could even prove that it's false, given the data that we have on preferred rotations of galaxies. If the speed of light was infinite, would everything in the universe happen simultaneously? No. You would just have something that's something. You would just have something like Newtonian dynamics being the governing mechanics rather than special relativity. Moon landing, fake or real? Like, definitely, obviously real. And if you think otherwise, then you're just disconnected from reality. Why a black hole rather than... Oh. He asked that question again. Or did it just pop up again for some reason? It's a good joke. What are your views on Hubble tension? I suspect that... Well, now I'm suspecting that it has something to do with how accurately we're measuring distances from supernovas. Why are you a Trump supporter? I'm definitely not. Most scientists aren't, turns out. What do you think happens with information in black hole? I think that it's probably preserved in Hawking radiation. By the way, I should chill for myself. I haven't done that in like the hour that we've been live. First things first, there's a Discord server. It's available to anybody who's 18 plus. You can find it in the description of the if you're watching on YouTube, or in my link tree if you're watching on TikTok. I might be sending out, I send out announcements on Discord all the time, announcements of when I'm live, when I have new videos, etc. You can ask me questions, you can ask other people questions there. I'm going to be sending out some announcements today that are probably important and you might want to see, so you should join the Discord. Second thing, if you want access to my debate notes, which I use during debates as just like a repository of papers that I can refer to, of facts that I can refer to, arguments, counter-arguments, and so on, the way to get those is to either become a member on YouTube, it's like $4 or $5 a month, or become any level member on Patreon. $4 or $5 a month or something like this, you can get access to the debate notes. Third thing, make sure to go follow the second YouTube channel. If you're watching on the horizontal, you're already watching on the right channel. If you're not watching horizontal, if you're watching on YouTube or if you're watching on TikTok, or if you're watching YouTube vertical, go follow the second channel. It only has 4,000 subs, and we should get that number way up. So yeah, that's me finished shilling. Let's go back to answering some questions. Do you think the eternal return of Poincare recurrence is possible? To my understanding of everything, it's not only possible, it's probable. Welcome to infinity. Poincare recurrence only works if you are in a finite configuration space. Now, if our universe does recollapse, and if our universe is finite, then yes, in principle, it's possible. Bacon and Bush sends $10. What is the weak force? I thought it was synonymous with the Higgs field, but I guess I'm wrong. So the Higgs field is involved in the weak force. It plays kind of a critical role in how the weak force happens, but the weak force is just another force. It has two different ways of functioning. It can either function via kind of like a transmutation process. So you can have an electron turn into an electron neutrino via the weak nuclear force. Or it can behave sort of like a very weak version of the electromagnetic force. You can have an electron, you can have, say, an electron bounce off of a Z boson, and the electron will either gain some momentum or lose some momentum or something like this. So it kind of has like two different modes. Those are the two different modes that are relevant. I don't know what's going on with the... Unless somebody's asking the same questions over and over again, for some reason it's glitchy. That's weird. What do you specialize in? What have you specialized in the past? So I do relativity and I do differential geometry. So relativity, I touch on things that involve black holes. I touch on things that involve like the early history of the universe. I touch on things like dark energy. I also just do some pure mathematics as well. Do you like chemistry or do you prefer equations? I know chemistry also has equations. I know very little about chemistry. Free intro to physics textbook would you recommend? Yeah, it's if you go to OpenStax, type in OpenStax and then Rice University and then Physics University Physics into Google, you will find a good free open source textbook or open textbook. I don't know if it's open source, but why are there 3 generations of matter? This is a big problem. We don't know. We just don't know. Have you ever listened to Battle Beast? Yes, I have. I like Beast and Blackmore, but I do like Battle Beast. I'm hungry. Many worlds interpretation. Do you believe in it? I lean that way, yeah. Could constants slowly change over time? I suppose in principle they could, but we don't have any evidence that they do. How much Earth gravity affects movement of the sun? Very, very little. Richard, thank you for the $5. I appreciate you. Oh, I should check to make sure I didn't get any cash apps or anything. Because there's a cash app and a buy me a coffee if you don't want to send money on YouTube or on TikTok, because YouTube and TikTok take a big chunk of the donations. If you want to support me, that is. You don't have to. Dork matter is also referred to as fan fiction. I've never heard of dork matter. Can you calculate the no. If the block universe is real, why do we experience it now? It's an illusion. So it might just be a feature of the way that like consciousness works. If gravity is purely geometric curvature of spacetime, how does a massless particle like a photon feel curvature without experiencing force? If it's purely geometric, then there's no feeling of anything. If spacetime is curved, that just means a straight path through spacetime ends up looking curved from like a naive perspective. How can we prove gravity? You can prove gravity using experiments from like dating all the way back to the 1700s using something called a Cavendish experiment. They're like really, really straightforward to do. Essentially, you put 2 heavy things close to each other and you measure the force between them. How can waterfalls keep going? How does it not run out of water on top? Well, because of rain, I guess, and like lakes and stuff and rivers. The Cryptid Monkey sends $10. What books would you recommend to learn about cosmic evolution and or the Big Bang? What books indeed? Indeed, what books? This book. It's always this book. This is the best book. It's a bit out of date, but it's still very good. There's also a book that came out fairly recently by a fellow named Niayesh Afshorty and what was his co-author's name? Niayesh Afshorty and Phil Halper. Also a good book. Haven't finished it yet, but it's a good book. It's called Battle of the Big Bang. It describes a whole bunch of different theories about what the Big Bang is and how it worked. Is that name Iranian? Yes, Niayesh Afshorty is Iranian. Yeah, he's an Iranian physicist. What is your take on the timescape model? I don't take it too seriously. Roughly, it relies on gravity not averaging out nicely, and we have good mathematical evidence to think that gravity should average out nicely. So the kind of the fundamental assumption probably just doesn't work. But, you know, it's always good to have a few people working on fringe stuff. Is P equals NP in your opinion? That is not in my field. What are your thoughts on Ed Witten? Dude's brilliant. Like mega brilliant. Why didn't you become a physics teacher or maybe a professor? Well, considering I had an interview to be one of those last week, who says I won't be? Black hole made of dark matter possible? Dark matter can't collapse. Can't undergo catastrophic, irreversible collapse like regular matter can. So you can't form a black hole just out of dark matter, at least not with the initial conditions that we're familiar with. Do you think that we can quantize gravity? I hope so. I definitely hope so. But maybe not. How do you feel about AMO physics? I don't know a lot about it. I do really like lasers though. Does the image of the CMB change over time, or is it a fixed history? I mean, in principle, it does change over time, but like cosmically slow. Big Bang Theory. Done. Theory doesn't mean guess. Theory means, you know, well-evidenced model. Do you believe aliens have come to Earth? No. Best way to study calculus? Just do practice problems. Like, that's what like, look, people want like quick and easy tips. It's a skill. You have to practice it. You have to put in the hours. Why can't dark matter collapse, or how do we know that? So in order for things to collapse, you have to basically be able to have friction and like have inelastic collisions. But as far as we can tell, dark matter can't do that. It doesn't heat up and get hot when it like bumps up next to other bits of dark matter. Angelo Garuso sends $5. What are your thoughts on dark flow? I don't know a lot about it, although I've heard of it. Let me... Oh, yeah, I have heard of this. I think this is the same kind of thing that is plausibly explained by this... God, there's so many... So I think that dark flow has the same issue as like the axis of evil, in that maybe there are some things that are just rare and that don't require an explanation. It's hard to say though. You were just answering money questions. This is like fundraising. Have you not been watching? Like, I've answered so many questions. Most of them don't send money. But in some sense, yeah, this is like fundraising. Yeah, so that it pays for my research. At least part of it. This pays for part of my research. Most interesting uni courses you took? General relativity was the most interesting course I took as an undergrad. How active is string theory in your department? Is it dying? String theory is pretty active in most places, but there'll be like 1 or 2 people at most universities. Some universities have large places, have large string theory contingents, but not often. Do you like Big Bang Theory, the show? I thought it was cute, at least at the beginning. It just became like a normal average sitcom in the later seasons, but yeah, I thought it was still fun. If the second law of thermodynamics drives systems towards higher entropy and organized matter represents a low energy state, does this create a statistical asymmetry? Yes. Yes, it absolutely does. Your views on ancient life on Mars? I think it's plausible. Communication with entangled particles over long distances possible or not? Not possible. In fact, mathematically provably so. How do you send a super chat on TikTok? You can't. You cannot send a super chat on TikTok. You can send donations and I will acknowledge you, but yeah, you can't send a super chat. Is there really a sterile particle-wise vacuum, like space itself is full of particles? Possibly. Actually, maybe I don't know what you mean. Maybe I don't know what you mean by that question. There is the possibility of things called like sterile neutrinos, which just don't do anything. And they might exist without doing anything, but... Is physics like hard in higher classes? I mean, it's a STEM field, so like, yeah, generally like, it's going to be challenging. Juan Novoa sends $5 to ask, if time travel is possible, would there be a difference for the process of going to the future or the past? Time travel is possible, but we can only do it to the future. And we're doing it to the future right now. We're traveling to the future in time. It's just kind of slow. We could travel more quickly to the future if we started accelerating very quickly or if we hung out near a black hole, but we can travel to the future, no problem. Traveling to the past seems like it's impossible. It requires a completely different kind of thing in order to make it happen. By the way, if you spam questions, I will not only not answer them, I will also mute you. So quit it. Could there be a relationship between matter that has fallen into a black hole and dark matter? Some people think so, but I'm pretty skeptical. Bacon and Bush sends $10. Oh, I already answered that. I don't know why some questions are being repeated. Are quantum computers the next big thing? Well, not really. They're like, they already exist. The thing is that it's not clear if they're better than regular computers at most things. At some things they're much better, but at most things they don't seem like they're much better. Eladio Santiago sends $5. Haven't taken math in like 4 years, taking physics 1 at university in winter quarter. Will I struggle, or what resources could I take to succeed? So you should definitely, it depends on how comfortable you are with algebra. If you're good in algebra, then you should refresh your calculus. If you're not good in algebra, you need to go do some refreshers, because if you're stuck trying to understand the mathematics of a lecture, like you're going to be getting a lecture, there will be mathematics on a blackboard. If you're struggling to understand the mathematics there, then you will not be paying attention to the physics that you're trying to learn. So you need to make sure that you're fluent enough in, regular algebra should be like back of your hand. Calculus, you should have a pretty good understanding there for physics 1. That will make your life a lot easier. If gravity is geometry, why does information seem to bend with it? I don't know what you mean by information bends with it. Is fluid mechanics hard to learn, and how can I learn the theory behind CF, classical fluid dynamics, before I hit uni? Fluid mechanics is really not like unless you're like specializing in that, it's just not really a thing that like is taught in a physics degree that much anymore. Do you learn differential equations in high school? Maybe if you take calculus, you'll learn some really basic ones, but not often, no. How do photons have energy if they're massless? There's a fundamental assertion in your question that things have to have mass in order to have energy, but that's just not true. Ask yourself why you think that that is true. Is the shape of a black hole being a sphere an illusion? What shape is it? Well, usually they're like, if they're spinning, they're like ellipsoidal. And so that is genuinely the shape of the event horizon. That's the shape of the point of no return. When we talk about what shape of black holes, we're talking about the shape of the event horizon. More so, why do they have momentum? Because so they have to have momentum, otherwise you wouldn't have momentum conservation. Let's just put it that way. But you can also, just from like the equations of motion, and from the action, I guess, from the action for electromagnetism, you can just prove that there is a momentum component of any electromagnetic wave, not just photons. E equals mc squared is not the full formula. The full formula is E squared equals mc squared squared plus pc squared, where p is the momentum. So as long as you have momentum, you can have energy. You don't need mass. But light carries information, doesn't that mean information bends too? I guess, but information is like a property of matter. So all that's happening is that like the light is bending, and so whatever properties is following that same path, whatever properties it has follow that same path. Is there a good analogy to describe what a black hole does to the matter it consumes? Well, we don't know what it does to the matter it consumes, besides it falling in and not being able to get out. What shape is the universe? As far as we can tell, the universe is flat. And that means not curved. It doesn't mean two-dimensional. It's still three-dimensional. It's just not curved as far as we can tell. Why not integrate quantum mechanics at quantities in a c times t event radius sphere rather than to infinity? Well, in quantum mechanics, standard quantum mechanics is non-relativistic, so you just assume the speed of light is infinite. In QFT, you do. You like, things only have compact support, and commutators are only commutators are 0 outside of the light cone and all these kinds of things. Wait, how can you get momentum without mass? The way momentum is defined, it's defined mathematically, and you can start from any system, and if the system has translation invariance, meaning if you like shift your coordinates one way or the other way, the physics don't change, then you end up with a momentum. And electromagnetism has that. You can write down the equations that govern electromagnetism, and then you can derive what the momentum has to be based off of the fact that it has time, or has a spatial translation invariance. This is from Noether's first theorem. Sorry, I'm getting a phone call. Sorry about that. Eladio Santiago sends $2 to ask, best way to catch up on calculus algebra, any recs? I don't know. I've never been in the position where I need to do that, and I've never like taught students who were doing that. So yeah, I don't know. These are probably better questions. Probably questions that are better suited to like maybe math professors who teach undergrad math a lot. I've never done that, so sorry. I know that's not helpful. Could two mathematically distinct universes be physically identical? Ooh, I don't know what it means for them to be mathematically distinct but physically identical. Do we know how magnets work? Yeah, we absolutely do. In fact, I have a video on that. Have you hydrated this stream? I have a lot. I'm also hungry, by the way. James Pesh sends $5 to ask, that takes mass though, or is that just an energy? Can you expound on that theorem? So Noether's theorem is it's a mathematical theorem. It's like a relationship between, okay, so I should probably back up. The way that we do physics these days is you start with something called an action. Action is basically, it's like a generalized, in classical systems, you can think of the action as the kinetic energy minus the potential energy of the system. And clearly, like, electromagnetic stuff can have energy, right? Now, for kind of like obvious reasons, like there's electric potential energy and so on. So what Noether's theorem says is if you start with an action, and that action has certain symmetry properties, meaning if you change around some of the terms and like the thing that you end up with doesn't change, like you shift some stuff in the formula, but the end result is still the same, then that implies certain properties about the system that you're describing. And one of the things that it implies is if the system doesn't change, if you move it left, right, up, down, back, forth, then that implies that there is a momentum quantity that's conserved. And so you can just check that this is true for electromagnetism, and that just implies that there is a momentum that's associated with the electromagnetic field. Cosmic Pickle sends $5 to ask, if B theory of time is true, does that mean the flow of time is an illusion? And if that's true, why do moments in time appear causally related? So you can have causal relation without having, while still having the flow of time being an illusion. I would still say that absolutely, even in the B theory of time, you have causal relations. Things are still limited by what things are still limited to occur by what they're nearby. Sorry, that's terribly phrased. Things still happen in a way that is influenced by only what's immediately nearby in a causal way. That's still fine. The illusion part is merely just that our clocks are synced up with our brain being in a particular state, and when our clock is in a different state, our brain is in a different state, and there's just a different synchronization that's happening there. I do have a video on this though, from a few weeks ago, so check it out. H2K Mello sends $2 to ask, how can we tell that the universe appears flat? It's a good question. Basically, what you do is you try to measure giant triangles. You try to measure the interior angles of giant triangles. So if you draw a triangle on a sheet of paper, which is flat, all of the angles add up to 180 degrees. But if you tried to draw a giant triangle on the surface of the Earth, like connecting, say, the North Pole to 2 points on the equator, that triangle would have more than 180 degrees. And so by basically looking at the size of triangles, you can determine what shape the universe is. I want to hear your thoughts about on 3I Atlas. It's a comet. It's an interstellar comet, but it's a comet. If everything in our universe were opposite parity, would there be different quantum interactions? Slightly. The parity quantum number is not conserved. It's just not. It's not a symmetry, rather, I should say. The angles of a 2-point shape add up to 360 degrees. What? Yeah, triangles can disprove annoying flat earthers, but then they have to believe the distances that you measure. What are the chances of a 500 gram ball quantum tunneling through a wall 20 centimeters wide, infinite tries? My guess is it's something like, well, it's hard to say, but I did a calculation similar to that for a hand tunneling through like a 2 centimeter wide wall, and it was 10 to the 10 to the 35. So very, very small. How common is the possibility of life in our universe? It could be very common. There might have been life on Mars. In fact, there was a recent announcement that they may have found evidence of life on Mars. Our physics is off. Prove it. Okay. Why, when an object is thrown in space, it eventually stops and doesn't keep going? This is merely a result of the expansion of the universe, but if that's only assuming that the expansion keeps going forever. And it's the same way that like waves get redshifted. They get stretched out. What rate does time slow as you approach the speed of light? There's a formula for it. It goes as 1 over the square root of your speed squared divide, or of 1 over the square root of 1 minus your speed squared divided by the speed of light squared. That's the ratio of their time to your time. Physicist sends $5 to ask, can you explain supersymmetry and its implication in string theory, and if you think string theory exists? So look, superstring theory it's a fairly straightforward idea, namely that for every type of matter particle, you have a force particle, and for every type of force particle, you have a matter particle. So you have an electron, which is a matter particle, and its supersymmetric partner is the selectron, which would be a spin 0 particle, which isn't a force technically, but it's a boson. And then for every type of boson, like a photon is spin 1, there would be a matter particle that corresponds to it. So in the case of the photon, it would be called the photino, which has spin 1/2. Now, the reason why we need this, or the reason why this is needed, is because in string theory, is because if you don't have it, in string theory, there's just no matter particles. There's only bosons. You need a way to get fermions, and so this would be a way to do it. You can impose supersymmetry, and then you can get matter particles in your string theory. Now, do I think string theory is correct? Or, I mean, it obviously exists. Like, it's a theory that you can write down, it exists. Do I think it's correct? Probably not for our universe, because supersymmetry doesn't seem to exist in our universe. But maybe it's a correct theory of quantum gravity in another universe. James Pesh sends $5 to ask, how do you attempt to convey to lay people the moments prior to Planck measurements? You don't, because we don't know anything about them. Why can't matter with mass travel at the speed of light? It would take infinite energy to get there. That's why. Y'all, we are just about done with the live stream. Oh, we have one more super chat. From Cosmic Pickle, is the replication crisis something we need to take seriously, or is it anti-science propaganda? In some fields, it is certainly something that needs to be taken seriously. It's not a particularly big issue in like physics and chemistry. It's probably not a particularly big issue in like geology. In like some parts of medicine, it's a big issue. Definitely in like psychology and sociology, it's a big issue. But it just depends on the science. All right, I'm gonna end the live here. Oh, I have a Cash App that I should read. So we got a $10 Cash App from Grimlock for because I can. No cut for YouTube. Well, I appreciate that that Grimlock. All right, I'm gonna end the live here. And we'll be back tomorrow for some more regularly scheduled debates at the normal time. I will see you guys then. Make sure to join the Discord server and consider becoming a member on YouTube if you want access to my debate notes. Take care, everybody.